All right, listen up, class. Okay, so for everyone that's paying attention, I did mention it already that there is a quiz on Friday. Hopefully people are actually going to be following along, and those people that are on YouTube watching this are going to see that we have a quiz coming up on Friday. Now, for our notes today, 3-4, this is hashtag what? 79. Today's date, 11/19? 19. All right, so let's go through. It says, find the value of each expression. So we're going to do a little bit of regrouping on this to show you that this is going to work. So if they're all being multiplied together, we could regroup the multiplication to make it a little bit easier. So what I could do is, instead of multiplying the 1/2 times a 5, I could go 1/2 times 4, which is 1/2 times 4. 2 times 5? 10. There we go. No, don't. Because there's certain basic things that you guys should know. Basic multiplication is necessary, especially if it's getting to the point where we're going to be doing factoring and you're going to have to understand what values are, like certain multiplications and common factors. Same thing goes for this. But for this, I'm going to show you guys something. So whenever I'm multiplying by a fraction, the top is a multiplication.
I do the Texas thing.
And the bottom is division. So whenever I'm doing a multiplication, the top is a multiplication, the bottom is division. So watch this. So we could do the top, which is 5 times 4 is 20, divided by 2, 10. Or I could have did it the other way, division first. So 4 divided by 2 times 5, 10. Now over here, please. All right, over here on this. So I'm going to regroup it where I'm doing my fractions together. So if I'm multiplying by 2 and dividing by 2, what could I do with those? What could I do if I'm multiplying by 2 and dividing by 2? Cross them out, right? Because what's 2 divided by 2? 1. So when I cancel something, it's actually 1. And then 3, so dividing by 3 and multiplying by 3, again, cross out. So it's going to be 1 times 7 times 1, which is? Now, over here, we're going to do the same thing. So it's 7 divided by 7, which gives me 1. So I'm going to those. And multiplying by 3 and dividing by 3, 1. So it's going to be 1 times 5 times 1, right? So my answer is? So putting in the calculator all the time isn't always the quickest. Trying to use your brain and teach your brain how to actually do this helps out a lot. Use exponent rules to explain why these expressions are equal to each other. So for this right here, that's a power to power. What do I do if it's a power to power? Multiply. This is what was on 3.1. On 3.1, on the back of 3.1, it has these notes. So if I'm taking a power to a power, that's a multiplication. So it's going to be 5 to the 1/3 times 2. Now, again, multiply by the top, right? So it's going to be 2 times 1 divided by 3 is just going to be 2 over 3. And now the other one. So this next one over here, I'm going to do the same thing, but I'm starting off with 5 squared times 1/3. Same thing happens. I multiply by the top, divide by the bottom. So 2 times 1 over 3. So it's still going to be 5 to the 2/3. Now, you guys, I need everyone look at yesterday's notes. On the back of yesterday's notes, I gave you a special thing. It was an A and B.
Oh, a power and a root.
Power and root. Okay, so now we're going to look at number 2 now. Okay, write this using radicals. Now, what is my power on this problem right here?
It's over there.
2, and my root is 3. Okay, so I know those aren't phones out right now, right? So it's going to be, it's 5, right? 5 squared, and my root is 3rd root. So I'm going to go 3rd root of 5 squared. Or I could write it with my root first, then the power. So it could be the 3rd root of 5 squared, like that. Both those are going to be correct. Now, for this next one, it says write 5 to the 4/3 using radicals. Okay, so what's my power? 4, and what is my root? 3. Okay, so watch this. It's going to be 3rd root of 5 to the 4th. Now, I'm going to go off to the side, and on the line paper, I'm going to actually do some more with this one, because this one actually is special. So it is an improper exponent. So everyone can see it's 5 to the 4/3. Now, that is an improper fraction, right? Say yes.
Yes.
Okay, improper fraction means the top is bigger than the bottom. So if I were to, I know that 3/3 is 1, isn't it? So I could rewrite this as 5 to the 1 and 1/3. Yes. So I'm rewriting it like that. Now, I'm going to rewrite it again, explaining what this is. So this is going to be 5 to the 1st times 5 to the 1/3. Because it's an improper fraction, I'm able to break it up like this. So the 1, 5 to the 1 is just 5, right? So what is going to be inside my radical? Just this 5 right here. So I could rewrite this. My answer for this one would be 5 cube root of 5. And I was able to do this because I had an improper exponent. Does that make sense? No? Okay. So, if you notice, I did this right here, right? So, I had 5 to the 4th right here, right? So, because of this right here, I have more than what this is. So, if I were to take, and let's do a square one. Let's do a square one. So if I take 5, the square root of 5, and square that, what do I get? That's just 5, right? Okay, so let's rewrite it though using an exponent. That's the same as saying 5 to the 2/2. That is my proper exponent. There's my 5 to the 1st, isn't it? Okay, so there's that. But now if I have more on top, so let's go back to this one up here. So I'm going to do this. So it's cube root 5 times 5 times 5 times 5. That's my 5 to the 4th. Yes? That's the 5 to the 4th. So I'm going to do this. So what I did is, by taking this piece out, that means right here, since this is a 2, and 2 and 2 is going to give me my whole right there, right? So if I regroup it, as in the cube root of 5 to the 3rd times cube root of 5. So this is a regrouping method right here. So it takes 3 to the 3rd, right? 3 to the 3rd, so 3/3 is going to give me my 1 whole, which is right here. So by taking this and rewriting it like this, I have this, which gives me my just 5, and this is left over. Is that better? Okay. All right, so let's take a look at, where are we at here? Okay. So for this, we're going to go through and fill these out. So if x is 0, 2 to the 0, and anything to the 0 power is 1. Okay, let's go to this one over here. What's 2 to the 1st power? 2. And this one over here, 2 to the 2nd power? Okay. So in a fraction, 1/3 is between 0 and 1, isn't it? 2/3 is also between 0 and 1, right? So my answer to these should be between 1 and 2, right? Okay. So it should be 1 point something for both of these. Okay, so it's going to be 1 point something. So it says decimal approximation. So, you know what? We're going to go straight to the calculator, even though it says without using a calculator. We're going to use calculator because it's on the back side. It says use the calculator anyway. So, right here, please take 2 and raise it to the 3rd power, or 1/3 power. So 2 to the 1/3 power. 1 point what? 2.5? Okay. What about 2 to the 2/3? 1.58? All right, does that seem right? As my fractionals get closer to 1, it goes from 1 to 2, and they're both right inside there, right? Okay, so we should know that's going to be in between those. All right, so now the 4/3, there's my improper fraction. So it's supposed to be between 2 and 4, isn't it? All right, so let's go ahead and try that. 2 to the 4/3. 2 point what? All right. What about 2 to the 5/3? 1.7? Okay. All right. Hey, does that work out? So in between the 1st power and the 2nd power, they should be between 2 and 4. Pacho's Petting Zoo. Not bad. Hold on, give me a second. Okay, sorry for those people in YouTube land that are following along. Okay, so now we got all these right here. Now the next thing that we're going to do is we're going to take my answers from this table and we're going to put it on these plots. So put our points in there. So again, anything to the 0 gave me 1. Okay, 1/3 power, 1.25. So there is right about there. 5.8. Right there. There. 4/3. 2.51. Right there. Thirds, 3.17. And 4. If you guys see, it is a gradual increase. in exponential. It's a gradual increase in exponential. When he gets back. All right. So, we've actually done all this already. So we put in the calculator. So we don't actually need to do this part. So let me go back to the back side. It says, let's investigate 2 to the 1/3. Write using radical notation. So, this 1 right here, what does the 1 represent? Power. And the bottom is the root. So it's going to be 2 to the first power. And then it is the cube root, right? So let's rewrite that. So it's going to be cube root of 2 to the first power. Is that super easy now? I'm hoping. Okay. Hoping no one's trying to fall asleep right now, even though they're sitting straight up. Okay. Pencils in hand. Help you not fall asleep. All right. Let's look at the next one. What do we do with my power to power? Multiply. So it's going to be 2 to the 1/3 times 3, right? Which gives me 2 to the 3/3. And that's going to be 2 to the first. Yes? No? Maybe? All right, raise your estimate from the table. Okay, we don't have to do this one because we already did this one. Okay, we already put in the calculator so we know what it was. So I'm saving time by putting stuff in the calculator. All right, so let's take a look at this one now. Let's investigate 2 to the 2/3 power. Write this using radical notation. So, what is my power? 2, and what is my root? So, I could write this, and I could say cube root of 2 squared, or I could say the cube root of 4. Because 2 squared is 4, isn't it? Okay, good. All right, so let's do this one now. Power to power? Multiply. So 2 to the 2/3 times 3. So when I'm multiplying fractions, I multiply the top and divide by the bottom, right? So 2 times 3 is? Divided by 3. So it's going to be 2 to the 6 over 3, which is 2 to the 2nd, which gives me a grand total of 4. Okay, so when we multiply a fraction, it's multiply the top and divide by the bottom. So 2 times 3 is 6, and then divide by 3. Okay? Yep. All right, and okay, questions? Super easy. A lot of stuff, if you know your exponent rules from the 3.1, okay, you could use that. Okay, I'm going to skip this right here because guess what? Yeah, exactly. So we're using the calculators already. So make sure you guys like, share, and subscribe, and hit that notification button. Make sure you visit the store. Okay, proceeds, benefit, helpless children somewhere. All right, so